All right, so let's talk about exponents for right now. All right, so any number that is not 0 to the power of 0 equals 1. Okay, so if this was 18 to the power of 0, it would be 1. If it was 118 to the power of 0, it would be 1. If it was 3,118 to the power of 0, it would be 1. Now, I've explained this in class before, but just in case. So 2 squared, we know, is 4. 2 to the third power is 8. 2 to the fourth power is 16. So if you haven't noticed, it's multiplying by 2. Okay? Well, if you were to go the other way, it would be dividing by 2. So the next one here would be 2, right? And the next one after that, which is 2 to the power of 0, would be dividing by 2 again, which would end up to be 1. So any number to the power of 0 is really it dividing by itself. So that's why it makes 1, because any number divided by itself is 1 except for 0. So 7 to the power of negative 3. So this is the introduction to negative exponents. Now, negative exponents doesn't mean the number is negative. All it means is that this entire thing is on the wrong side of the fraction. Okay, that negative is screaming, I'm on the wrong side of the fraction. So when I look at it, I kind of make it look like this. Like, hey, I'm on the wrong side of the fraction. That's what it's yelling. So to fix that, it goes on the bottom of this fraction. And now that it's in the correct location, it's no longer screaming, so it's no longer negative. Mr. Cashers, what fraction are you talking about? This is not in a fraction. Well, if I had the number 7 and I said put it in a fraction, you'd go like this. You'd put a 1 underneath it. Well, that's the same thing going on here. If I said this is on the wrong side of the fraction and you don't see the fraction, well, this exists even though it's not there. So now it is. So now if you move it to the other side, it becomes 7 to the third power underneath 1. Now this one, again, this is screaming, I'm on the wrong side of the fraction. So where it belongs is on the top. So now, if I were to write it on the top of the fraction, it would be positive. But again, this down here is pointless, so it really just changes to that. Simple concept. Negatives do exist. Okay, like 3 to the power of 5 divided by 3 to the power of 8. The answer for this would be 3 to the power of negative 3. So negative exponents can actually be answers to those as well. All right, next board over here, scientific notation. So scientific notation, the number in that first space when you're writing scientific notation times 10 to the power. So scientific notation looks like this. A number times 10 to the power of something else. Now this number can be 1 and then go all the way up to 10, but it can't be 10. So, and the exponent here can be positive or negative depending on if you were making a very large number or a number less than 1. It's still positive though. Okay? And if it's negative, it has to be greater than 1. You know what I mean. So if you're making a decimal point like this, okay, you'll be using a negative exponent. If you're making a large number like this, you're going to be using a positive exponent. So here it has to be between 1 and 10. So here is where the decimal point is in this number. It's right here. Okay? Now, its new location has to be somewhere that makes the number between 1 and 10. So where can I move the dot? That would be too big, too big, too big, still too big. 5.01 is more than 1, less than 10. 0.51 is too small, so it has to go here. It's the only place the dot can go to make a number between 1 and 10. So 5.01. And then I have to figure out what number it goes here. Now this is a very large number, okay? It's not a decimal point. It is just a 501,000. So all I have to do is figure out how many times did I move the dot from its old location to its new location. So 1, 2, 3, 4, 5. So this number is 5. Now this one over here, I'm going to do the same thing, write it in scientific notation. So now I have to move the dot to its new location. Luckily here they gave me where the dot is. It's right there. That one we had to actually put it there. This one's been given. Now where can I move this dot to make it a number between 1 and 10? Right here. So that's its new location. So now 1.3 goes in the front times 10 to the power of, what's the exponent? Well, I know it's negative because this is a decimal point. Okay, now I gotta think, how many times did I move that dot? Well, here's where it started. 1, 2, 3, 4, 5, 6, 7. And that's the answer for that. So let's work on this the other way. What if I showed you it and asked you to do the actual math behind it? So here, 1.93, so this is 1.93, right? And they moved the decimal point 7 times. And 7 times means I'm making it bigger, okay? It's not a negative number, so I'm making this number bigger by 7 movements of the decimal point. So 1, 2, 3, 4, 5, 6, 7. All these empty spots get filled in with zeros. So now I know the number has 5 zeros. So 1, 9, 3, 1, 2, 3, 4, 5. And there's a comma here and a comma here. And there's my number that created. Okay, let's work over here. This is 1.56, so I'm going to put 1.56. And I'm going to move this decimal point, making it into a very small number, meaning I'm moving it to the left on 5 times. So let's erase a little bit of this, give myself some space. And it's going to be 1, 2, 3, 4, 5. Here's our new location. All of these spaces get filled in with zeros. So now it is 0 point, and then behind the decimal point is 1, 2, 3, 4 zeros. 1, 2, 3, 4, and then 1, 5, 6. All right? Why does the negative exponent do that? Because you're multiplying by 10 to the power of negative 5, meaning you're multiplying by 1/10 to the 5th power, which means you're dividing by 10 5 times. And when you divide by 10, it moves the decimal point, making the number smaller. All right, let's go to here. How do you multiply scientific notation? Very simply. Now, when you're multiplying these two, okay, all of this stuff is multiplying. In reality, you could write it like this. In reality, you could write it with none of this. Because when you're multiplying, the order doesn't matter. 3 times 5, 5 times 3. The order doesn't matter when you're multiplying. And all of these things are multiplying. But what we're going to do, because we have to keep the answer in scientific notation, is we're going to multiply the things that keep it in scientific notation. Okay, you'll see what I mean in a second. So what we're going to do is multiply this with this. So the number with the number. That seems obvious. And we're actually going to do what it says in the center. Multiply. So 3.1 multiplied by 1.8 is going to give us, that's 8, that's 24, add a 0, that's 1, 3, that's going to be 8, that's going to be 5, that's going to be 5. So our answer is 5.58. So I know the first part of our thing is 5.58 times 10 to the power of, now we're looking at this. This is going to multiply with this, okay? And if you have the same base and you're multiplying, the exponents are just going to add. So it's going to be 5 and 3, and that makes 8. All right? If you watched my previous video, you should have already known what I was going to do with the tens, but I guess we'll see. All right, here we go. So this one, this is the same concept, okay? Now, this is going to be dividing with this, okay? So 8.1 divided by 3. So we do 8.1 divided by 3. That's 2. That's going to be 6. Subtract. You get 2. Bring down the 1. How many 3 is going to 21? Decimal point is going here. That's going to be 7. That's going to be 21. Subtract, you get 0. So that's going to be 2.7. So 2.7, let me write in a darker ink here. 2.7 is going to be going in the front of the scientific notation. Times 10 to the power of... Now, when these divide, when this and this divide, the exponents actually subtract. So there's a possibility of getting a negative result at the end. But in this scenario, we are going to get a positive result because 13 minus 5 is going to be 8. All right, next one here. So this next work kind of reminds me of when you did fractions. Okay, these when you add and subtract fractions, the rule is the denominators have to be the same. For this one, if you want to add and subtract scientific notations, the exponents need to be the same. So here they are the same. So you're simply going to add this with that. Okay, that's going to be 8.3 times 10. The exponents for the 10s are going to do nothing. They're not going to change at all. Just like the denominator when you were adding fractions. What did the denominator do when you finally got them equal? Nothing. Just went to the end. Same thing happens here. That's why they're so similar in my head. Now, the adding and subtracting are all the same, so I'm not going to do a subtracting. But I do want to go over the example. What happens if the denominators are different? Okay? Now, in the way that I do it, I always change the smaller number. Okay? So, this is going to stay exactly the same. Okay? Now, this is a smaller number. 5.2 times 10 to the power of 4 is definitely smaller, and the decimal points are not going to line up because this is only moving the decimal point 4 times, and this one's moving it 5 times. So what we're going to do, I need this to move 5 times. Okay? Now remember, they went 1, 2, 3, 4. I need it to be 5. So now the new decimal point, okay, just for the adding, not the final answer, is going to be 0.52 because I moved this over there. And moving it an extra time increases that number to 5. Now that both of these are 5, I can finally add it. Okay? Now this is not a final answer, so this is acceptable just for now. When we get the final answer, it will be in the right way. So it's going to be 3.1 plus 0.52. So that's going to be 3.62 times 10 to the power of 5. And there we go. Okay? That's a very good thing to know because if you ever multiply or you divide or something and your answer is bigger, let's say your answer at the end of a problem is this. It's 13.5 times 10 to the 6. If you get an answer like that, you can't leave the final answer like that, which means you're going to have to move this one more time to make 1.35 times 10. I moved it one extra time, so it should be 7. And that's it.